Good morning, afternoon, or evening, whichever time of day you happen to be watching this video. Today our topic is perfect squares and approximating square roots. Go ahead and put that heading at the top of your page, including the date and the page number. And your objective today is, I know the squares of the whole numbers from 0 to 15 and can approximate, that's an important word, the square roots of numbers that are not perfect squares. Before we dive into this actual lesson, let's talk for a minute about what a perfect square is. A perfect square is any number that is the product of a whole number multiplied by itself. For example, if I take the whole number 3 and I multiply it by itself, which is called squaring the number, I end up with 9. 9 is a perfect square. If I take 6 and I multiply it by itself, I square it, my perfect square of 6 is going to be 36. So a perfect square is a number that is a whole number multiplied by itself. That gives you your perfect square. We're going to be dealing a lot today with numbers that aren't perfect squares, but we're going to be using the idea of a perfect square to help us approximate, remember I said that word was important, approximate the square roots of a variety of numbers. So on this same page, I want you to make a little list. Put the little subheading, perfect squares from 0 to 15, and then number 1, 0 through 15. If you have to use 2 columns, that's fine. If you have enough room to just go all in 1 column, that's great as well. And I'm going to count down from 10. Make sure you pause the video before I get to 0. And I want you to pause and try and figure out as many of these perfect squares as you can. So pause your video. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. All right, when we look at our perfect squares, remember it's just the number multiplied by itself. So these are the perfect squares for 0 through 8. These are the perfect squares for 9 through 15. You need to have these memorized. If you have to spend your time on the test figuring out, okay, what's 11 times 11 and what's 14 times 14, you are going to run out of time on the test to actually find the square root approximations. So these are things you just have to memorize. Remember on the last unit how I told you you had to memorize the properties of numbers? And most of you didn't actually do that. And we had trouble on the unit test because you didn't know what the properties of numbers were. Here's an example where you need to learn from that mistake. I'm telling you right now, you must know the perfect squares from 0 to 15. So make flashcards, quiz yourself, have somebody else quiz you. Cover up the answers in your notebook and then uncover them as you try and guess them to see if you got them right or not. Do whatever it takes to make sure that you know those perfect squares. Moving on, go on to the next page of your notebook and let's actually talk about how we approximate square roots. Before we actually get into it though, we need to check something. When you're given a math problem, the very first step you should ever do, step 1, is check your directions. And it becomes especially important when you're dealing with square roots because sometimes a question will ask you to estimate the square root to the nearest integer or to the nearest tenth. Other times, a question will ask you to find an exact value. And it's two very different methods for doing these different things. And I have a lot of students make the mistake of not reading the directions and then ending up doing the wrong thing. So step 1, check your directions. I want you guys to write all this down on that page in your notebook. Pause if you need to. Okay, so after we've done step 1 and we've checked our directions, step 2 is where those perfect squares come into play. All right, so we're going to make a list of our perfect squares. We've got 4 times 4 is 16, 5 times 5 is 25, on and on and on and on. And what we're looking for is, let's say our number is, I don't know, 30, and we're trying to find the approximate square root of 30. Well, 30 is going to fall here. It's going to fall between 25 and 36. So I know that the square root of 30 is going to be somewhere between 5 and 6. So we are making an approximation of where that square root is. And then you need to ask yourself, is your number, in this case 30, closer to the number before it or after it? So 30 is 5 away from 25 and it's 6 away from 36. Once we figure that out, it's closer to 25 but not by much. Our step 3 is to find the square root of the closest perfect square, in this case 25, and that would give us the estimated square root of 30, which would be 5. But you can take it to the next level, guys. You can say, okay, well, yes, technically it's closer to 25, but it's really closer to halfway in between 25 and 36. So what you can do then is you can say, all right, well, the square root of 30 is really approximately, that's a lovely symbol for approximately, it's approximately 5.5, and you can estimate it to the tenths place value with pretty good accuracy. Now, if I were to go and actually check this square root of 30 with a calculator, I have my handy dandy calculator, and I'm going to take, that's cube root, where's my square root button? There it is. Square root of 30, and I end up getting 5.477 blah 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 blah. It is really, really, really close to 5.5, so my estimation was pretty good. We're going to practice some more of these later on, but before we do, I want to make a really important distinction. And you can write a little note here on the bottom of this page. When you're finding square roots, that's a symbol for square root. If you're finding the square root of something that is a perfect square, for example, 36, the square root of 36 is going to be a rational number. Because the square root of 36 is very simply 6. And we know that 6 is a rational number. It's a whole number, therefore it has to be a rational number. But if I'm taking the square root of a number that is not a perfect square, for example 30, the answer that I come up with is going to be an irrational number. Always, always, always. We can say that it is approximately 5.5, but in reality, when we take the square root of 30, the decimal goes on and on and on and on, and it doesn't repeat, it doesn't end, which makes it an irrational number. When you go to put it in a calculator, you might say, but Mrs. Ott, it ends in the calculator. Look what your calculator did. It ended. Well, yeah, but calculators can only show so many numbers, guys. Just to realize, remember that if you take the square root of a number that is not a perfect square, it is irrational. Okay, how am I doing on time? 8 minutes? Great. Let's go to the next topic. Let's say if you asked yourself that first question of check your directions, figure out whether it is an exact value or estimating to the nearest integer, then you have to say, okay, well, what if it is something that I'm trying to find an exact value of? I don't know why it's not letting me type a 2 there. This should say step 2. So ask yourself first, is it a perfect square? If it's not a perfect square, you can't find the exact absolute value. That goes back to the discussion that the square root of a number that is not a perfect square is irrational. You're not going to be able to find the exact value. You're going to have to type it into the calculator and get an approximation. But if it asks you to find an exact value and the number inside isn't a perfect square, just a little hint, they want you to use a calculator. They're kind of sort of wrong because even using a calculator, you're not going to find that exact value because it's an irrational number. But if it asks you to find an exact value of something that is not a perfect square, using a calculator is what they're asking you to do. So jot down these notes. I hope you had room on this last page where we took these notes. If you didn't, you can just go to the next page and we'll talk about what to call that page when you come to class tomorrow. Let's practice a couple of these because I kind of think these are fun. I have a number line here and I have a random number generator. I can click it and it'll give me any number between 0 and 225. 225 should stick out in your mind because you might remember I need you to know the perfect squares from 0 to 15, and the perfect square of 15 is 225. So we have this random number generator. And let's go ahead and go with the number 74. First thing we need to do is say what two perfect squares is 74 between? And here's where you just absolutely have to know your perfect squares. I've been doing this long enough that I know 74 is between 81, which is the perfect square of 9, and the next lower perfect square is 64, which is the perfect square of 8. Notice how I'm using a number line? A number line can really help you figure out that approximation of where 74 should go. Because if you put one perfect square on one side of the number line and the other perfect square on the other side of the number line, you can kind of figure out where 74 should go. Is it really close to 64? No, it's like 10 away from 64. Is it really close to 81? Well, it's 7 away from 81, so I guess it's closer to 81 than it is to 64, but not by a whole lot. So maybe 74 is going to go right about there. Okay, and guys, yeah, it's not a perfect science. It's a little bit of a guessing game. So we know that the square root of 74 is going to be between 8 and 9, and it's going to be a little closer to 9. So I'm going to make an approximation. I'm going to say, that would be like my halfway point. So it's about, using that approximate symbol, 8 point, let's say 7. Okay, because it's not right there, but it's not too close to 9. I'm going to go in my calculator now, and I'm going to find out what the square root of 74 actually is. So I'm going to go here. Square root of 74 gives me, drumroll please, 8.6. Oh, I estimated a little bit on the high end. But you know what? That's okay. As long as you're only off by like a tenth, that's perfectly fine. All right. Now, if you said your estimate was 8.1, then we'd have to have a conversation because clearly 74 is not that close to 64. Let's try another one. I want you to do this one on the next page in your notebook. And you can just label this square root approximations examples. Okay, and I'm going to click this random number generator, and I want you in your notebook to make a number line and see if you can come up with the square root approximation of 146. I'm going to count down from 10. Pause your computer while I'm counting so that you can try this on your own, and then I will go ahead and show you the answer. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, guys, you should have known that 146 was between the perfect squares 144 and 169. The square roots of those numbers are 12 and 13. If I go to put 146 kind of where it should go on this number line, it's clearly really close to 144. Like right up next to it. It's only 2 away. Versus it's 23 numbers away from 169. So it's really close to this perfect square. So I'm going to say that my approximation is about 12.1, just past 12. If I go to my calculator, I see that it's actually 12.08, blah, blah, blah. That's really close to 12.1. So if you didn't get 12.1, you might want to rewatch that whole section about how to approximate square roots, because I think you might need a little more practice. Let's go ahead and erase this, and I'm going to give you another one. You ready? Here goes. 222. I'm only going to count to 5 this time. Pause the video and then try it out. 5, 4, 3, 2, 1. Okay, so 225 is between the perfect squares 196 down here and 225 up here. The square root of 196 is 14, and the square root of 225 is 15. That means we know that our square root of 222 has to be somewhere in between 14 and 15. So if I look for where 222 should go between, you know what, that looks like a 1. Let me fix that. 222. between 196 and 225, it's going to be a lot closer to 225 because it is 22, 26 numbers away from 196. So it's going to be way up here, like almost right next to it. So I'm going to make an approximation that my square root of 225, let's say it's 14.9, approximately. Use your approximate symbols. If we stick that in the calculator, we see 222. I have 14.89966 blah blah. That's really close to 14.9. If you had an approximation somewhere near that within a tenth, like 14.8 or no, you couldn't do 15.0 because that's the perfect square of 225. If you had 14.8 or 14.9, you did a good job on that one. Okay, what I'd like you to do now is when you turn in this assignment onto Edmodo, I want you to type a little reflection. Oh gosh, I'm at 15:45. I'll hurry up. I want you to answer this question. What is the most confusing part of today's lesson? Question mark. What are you having the most difficulty with? Type your answer into Edmodo, and I will respond to you after you type it in. Thanks, guys. Sorry it was 16 minutes long. I will try harder next time. Bye-bye.